stability of a control system, I just want to tell you that what is process. So, as you know, the process is something is input and something is output. As you know, like this is process, something is input and something is output. X t is the real time input and y t is the real time output. So, x t means the time dependent input and y t is the time dependent output, but there is no correlation between the x t and y t. So, the Laplace transform occur to convert x t into x s, and there is a correlation between x s and y s, that is called transfer function. G s is equal to y s by x s. So, what is transfer function? Transfer function is basically the ratio of the Laplace transform of the output in deviation form to the Laplace transform of the input in deviation form. So, that is transfer function. So, there is a correlation between x s and y s, that is called transfer function. To get the y t means real time output, we just we just take the Laplace inverse, we just take the Laplace inverse of y s, that is called y t. So, the thing is that I just want to say that if you are working on a process and you have some input, so always you will get the real time output with the help of the Laplace transform and the transfer function, that is the correlation between the x s and y s. So, now I just want to tell you a simple stir tank heater. So, in that case I am taking a tank, in this tank you are getting some water at a desired temperature, and like in this tank you are getting the 40° centigrade temperature at a inlet. What is this? This is the temperature measurement device like thermometer, or it may be any measuring device. It is connected to the controller. What is the need of controller? Controller is basically used to minimize the error which is occurring is in the system, that is further connected to the final control element. What is final control element? Final control element is just nothing, that is basically to enhance, to increase or decrease the temperature, like it may be any electric power and steam, or it may be any heating device, that is further connected to the process. Like I am taking an example, like the temperature is coming from the inlet is 40° centigrade temperature, but you need 60° centigrade temperature as a desired value. So, the temperature of the process is 40° centigrade. Thermometer or like temperature measurement element is sense the 40° centigrade. So, the Tm, what is Tm? The measured temperature, that is 40° centigrade, and the Tr is the set point temperature which you give in 60° centigrade. So, what is the error? Error is basically Tr difference Tm, means 60 difference 40, that is 20° centigrade. It goes to the final control element, means it directed to the final control element that you enhance, you increase your temperature. So, the electric power or steam just start to increasing the temperature of the process, it increasingly. After some time, like the temperature is raises up to 50° centigrade, the same thing is occur, it sends 50° centigrade and send to the signal into the controller, and you got the error 10° centigrade. After that, like same thing is happening, it again raises the temperature, like you get 55, the same thing is happening, you got the error 5° centigrade. After that, like you got the 60° centigrade, ठीक है, that means the desired value. So it sends the temperature 60 degree centigrade. So the error is 0, means you achieved the goal. So that's whole thing is called system, that's whole thing is called system, and the individual part like that's the process, that's the process, that's the controller, that's the controller, that's the final control element, or that's the measuring element. So what is process? It may be any first order, second order or nth order system. What is controller? It may be any type like P controller, PI controller, PD or PID. What is measuring element? It may be any temperature measurement devices in case of temperature. If I am taking the temperature as an process variable, if I am taking pressure, so it may be any pressure measurement device. What is final control element? It may be any heating device in case of temperature, and it is any it may be any pressure controlling device in case of if I am taking the if I am taking pressure as a process variable. So the whole the combined of the all transfer functions या all elements we called system, we called system. So the thing is that what is the stability of the system? Stability means if you are giving bounded input, if you are giving bounded input, you always get bounded output. In case of unstable system, if you are giving bounded input and you are not getting bounded output, means you are getting output is in fluctuation mode, is in increasing order or it is in decreasing order, that is called unstable system. So here you can see the stable system or dynamic system considered to be stable if for every bounded input it produces a bounded output regardless of its initial state. And unstable system, a system considered to be unstable if every bounded input it does not produce bounded output, means it produce fluctuation or the random behavior is in output, that is called unstable system. Like you can see the like for an example ramp function. So that is the behavior of a unstable system in both the picture. Now I just told you about the system in my first slide, in which I took an example of stir tank heater. I just converted that particular system is into the block diagram by taking the each element is into the transfer function. I already told you that what is transfer function. So I just converted process into the transfer function of GP, measuring element is into the GM, final control element is into the GV, and the controller is into the transfer function GC, and converted is into the block diagram. Here you can see. So the thing is occurring same as the as is in the process. So like the process starts from here, load means the inlet temperature is coming from here, it goes to the process, it goes to the process, from process you get you just connect it with the measuring element, that what you are getting temperature from the process, and then it connected to the controller, that is the base, that is set point, that is basically the set point, and the error is occurring basically here. So that is basically Tm, that is Tr, and error is Tr difference Tm, and error goes to the controller and then further instructed to the final control element to control the behavior or control the error of the system. That basically the diagram of the stir tank heater. Now I just told you that I just converted is into the transfer function form. So, controller is into GC, final control element is into GV, process into GP, load into U, set point into R, output into C, and measuring element into GM. Now, I already told you about the transfer function of the various elements, like GC is denote to the transfer function of controller, GV denotes to the transfer function of the final control element, GP for process, GM transfer function of measuring element, R set point, C output, U load variable. So, I am just taking the overall transfer function for that block diagram. So, for finding the block diagram for feedback control system, the overall transfer function is equal to the G overall equal to pi forward upon 1 plus pi loop. Pi forward upon 1 plus pi loop, that is G overall. So, here we are seeing is in process that we have three things like set point, load and the output. We have two term occur is into that system, that is called servo problem and regulator problem. What is servo problem? Servo problem is set point change and load fix. What is regulator problem? Regulator problem is load change and set point fix. But to finding the G overall, I am taking both of the things simultaneously. Like here you can see C equal to pi forward. Pi forward means you can see here the elements, the transfer function occurring is into the forward path from the set point to the output. In case of servo problem, means set point change and load fix means U equal to 0. So, is in forward path, if I am taking like GC, GV and GP are occurring is into the series, is in forward path. So, that is pi forward. GC, GV and GP, that is the forward path upon 1 plus pi loop. Pi loop means the transfer function is occurring is in all over the loop, like GC, GV, GP and GM, that is the loop. So, pi forward upon 1 plus pi loop into R. What is R? Is basically for the set point. So, if I'll get individually in case of servo problem and regulator problem, so that will be C by R equal to GC, GV, GP upon 1 plus GC, GV, GP, GM, that is for servo problem. Now, C by U equal to GP upon why I will write GP, you can see here, if I will start from U to the output, only GP transfer function occur in between. So, is in forward path only GPs occur. So, I write GP only, and pi loop is same for both of the servo problem and as well as for regulator problem. So, you will write 1 plus GC, GV, GP and GM, that is for regulator problem. If I will combine both of the things, I will get that is the overall transfer function by taking servo problem and regulator problem simultaneously. You can see here, if I want to get the transfer function for regulator problem, so that means set point will be 0. You will see set point will be 0. I will put r equal to 0, r equal to 0, that means that term will be 0. So, you can easily find out C by u. C by u will be that thing, it will written already here. And if I will get overall transfer function for servo problem, means set point change, means load equal to 0. So, I will write u equal to 0. So, that means that term will be vanish. So, you can easily find out C by R, that will be here already written here, GC GV GP upon 1 plus GC GV GP GM. So, that is for servo problem, that is for regulator problem, and that is overall transfer function for the system. Now, I already told that what is servo problem is set point change and load fix. In case of regulator problem, set point fix and load change. For servo problem and the overall transfer function already I wrote here, and for regulator problem I already wrote here. Now, the thing is that I already told you that you have a process, you have some input and you have some output. So, if you are changing the input, the simultaneously change is into the output. So, is in process dynamics and control, you see that how your system is behaving. If you are giving stable input or bounded input and you are getting stable output or bounded output, that means your system is stable. And if you are giving stable input or bounded input and you are not getting stable output or bounded output, that means your system is unstable. So, like the unit step change applied to the set point. Set point means like I am giving a step change is into the input. Step change means like by 1 unit or 2 unit, or it may be any other unit. So, I am giving like I am taking the servo problem, means C by R equal to GC GV GP upon 1 plus GC GP GV GM, and I am giving the step change means R means is equal to 1 by S. For unit step change I will take 1 by S in the form of the Laplace transform, because ut is converted to the 1 by S in case of unit step change. So, I took 1 by S. So, you will get like C equal to GC GV GP upon some roots of is in the denominator. One more thing I just want to tell you that 1 plus pi loop or 1 plus GC GV GP GM, I also called that thing characteristic equation. And to find out the stability of the system, characteristic equation plays an very important role. Means with the help of characteristic equation we can easily find out that our system is stable or not. How? We will see is in next slide. So, I told you that what is characteristic equation, that is nothing 1 plus pi loop, or you can also say 1 plus G open, both are the same thing. 1 plus G open or 1 plus pi loop is equal to 0. So, what is this? 1 plus G open equal to 0, that is characteristic equation. So, 1 plus GC GV GP GM equal to 0, and it have some roots like R1 R2 R3 up to Rn, that depend on the transfer function of the system, like what GC contains, what GP contains, what GV contains and what GM contains. Just put all the transfer function is into the characteristic equation and converted it is into the polynomial form. So, to find out the stability of the system, we just check the behavior of that roots, that where it lies. So, now you can see if your roots means roots of your characteristic equation, if your roots lies on the left hand side of the imaginary plane, so that means your system is stable, and if your roots lies on the right side of the imaginary plane, so that means your system is unstable. Like if you have n number of roots, it may be quite possible in such cases, like you have n number of roots, like I am taking that you have 3 roots. If all 3 roots are lies is into the left hand side, so that means your system is stable. If all 3 roots are lies is into the right hand side, that means your system is unstable. And if all 3 roots are lies is into the imaginary plane, that means your system is on the verge of instability, means by changing the minor occur is into the roots, it may be stable or it may be unstable. Now, the fourth thing, it may be quite possible is in 3 roots, 2 roots are lies is into the left hand side and 1 root is lies on the imaginary plane. So, in that case also your system is on the verge of instability, means by slight changing is into the imaginary root, it may be stable or it may be unstable. So, here you can see like a linear system is unstable if any root of its characteristic equation are to the right side of the imaginary axis. All the things which I told you written is into the bottom to find out the stability of the system. I am taking an example to define the stability of the system. So, here is the example, like you can see in this example we have a feedback control system. In this I have GC, means the transfer function of the controller, which is 10 into 0.5s plus 1 by s, that is basically PI controller. Means the transfer function of the PI controller. And you have GP means the transfer function of the process, it is 1 upon 2s plus 1, that is basically first order system. You know that like the transfer function of the first order system is equal to like 1 upon tau s plus 1, you can see that value of tau is 2. So, that is first order system. What is GM? GM is basically the transfer function of the measuring element, GM equal to 1. So, you have the number of elements is occurring is that particular feedback control system. So, the step, what is the step to find out the stability of a control system in simply way? So, just find out the characteristic equation. How you will find out the characteristic equation? That is just nothing, just 1 plus G open equal to 0, 1 plus G open equal to 0, or that is the denominator of your overall transfer function in case of servo problem as well as for regulator problem. Characteristic equation will be same for servo problem and for regulator problem. There is no change occur in both of them. In both cases characteristic equation will be same. So, like 1 plus GC GP GM equal to 0. What is GC GP GM? That is basically G open. So, that is characteristic equation. I just put the values of the different element like controller, process and measuring element is into the characteristic equation. So, I just wrote 1 plus the value here, Gp here and the Gm here equal to 0 and just solve simply. So, you will get like the after solving that particular equation you get a quadratic equation or polynomial quadratic equation like s square plus 3s plus 5 equal to 0. You can easily get the roots of that characteristic equation by Sridharacharya rule. You know that like s equal to minus b plus minus root of b square minus 4ac by 2a, that is Sridharacharya rule simply. So, I just find the root from the that particular quadratic equation and I will get s equal to minus 3 plus minus root of minus 11 by 2. One more thing, to find out the roots of the characteristic equation, we always see only the real part of the complex number, means the stability is directly dependent on the real part only, means you will not consider the complex part. So, I got the minus 3 plus minus root of minus 11 by 2 and here you can see the like both roots of that particular characteristic equation or quadratic equation like s1 equal to minus 3 by 2 plus j root 11 by 2 and s2 equal to minus 3 by 2 minus j root 11 by 2. I already told you that we will see only the real part. Real part means minus 3 by 2 and minus 3 by 2. So, both are the negative parts, both contains the negative real part. That means it exists on the left hand side of the imaginary plane, that means your system is stable. So, by that particular process by that particular rule you can easily find out the stability of a system. But the thing is that if you have the like critical system and so we have the number of methods to find out the stability of a system. So, for finding out the stability of a system we have basically 3 methods. The first one is the Raut